When scientists try to understand a phenomenon like magnetism, it's difficult because it happens at such a micro small level within matter, down at the atomic level, the electron level, that you can't really see it even with the best electron microscope. And so we have to come up with different kinds of experiments to see if we can figure out how this all works. And one of the things that I would like to come out of our discussion today, where I hope we're going to learn quite a bit about magnetism, we're not going to learn enough to really understand the secret of how it works, but we've learned a lot about it. And we're going to learn some of that and be able to understand it. But I also would like a bonus. We're getting ready for the science fair. A lot of you are thinking about, what am I going to do for the science fair? Well, what if we were to use the scientific method to deduce or to discover things that we can't even see? Scientists wanted to see very small things, so they invented a microscope. Scientists wanted to see things very far away, so they invented a telescope. And each of these things let us see more. But eventually, it's designing these clever experiments so that we can figure things out. And I'd like to have you kind of explore that with me as we look at these mystery boxes, okay? Welcome to Area 51. Today we're going to learn some things about magnets. First of all, we need to discover magnets. And the first magnets were discovered in a little bag like this, or maybe not in a bag, but outdoors. Inside here, I have some rocks, some stones. In fact, these are stones that are found naturally in nature. They're called lodestones. And when they were found, it was discovered that they had properties of magnets. Now here's some little magnets, like little compasses. In fact, I'm going to get this big compass over here, and you can see it's got a needle in here that points towards the north. So I could turn this so that it's right. Okay, now it's pointing north. Good. Now if I take one of these lodestones and put it down here by it, the magnet can see the magnetic property of these stones. So in nature, we find these. Now, turns out that there's a lot of lodestones. This is an iron mineral deposit, but there are a lot of them that are not magnetized. They can be magnetized by putting them in a strong magnetic field or even rubbing them against a very powerful magnet, but in nature, they're not. A lot of scientists have really fascinated themselves, well, why are some of these stones magnetic naturally? And it's the theory of some people, maybe they were stricken by lightning or something to have their magnetic properties. But this is some of the first magnets that we ever experienced was lodestones. I'm going to put them over there, out of the way for a minute. And you see these little compasses. These are the same kind of wheels that are inside of a compass, which are little magnets. And the red part is magnetized towards South Pole, the white part towards North Pole. This happens to be a big magnet, a big ring magnet. And on one side it's magnetized North Pole, the other side South Pole. Watch what happens to these little compass guys when I bring this close. Okay, can you see that they all are paying attention to him? Now watch what happens if I push him clear down. They flip because he's North Pole on one side and South Pole on the other. So watch all of these little red tips as I pull them out. Kind of fun, isn't it? So this is a piece of metal that has been magnetized, and this happens to be an alloy that's made specifically to form magnets, so it's a very strong one. Another way to see this magnetic field coming out of here is on this little case of tiny magnets. Inside of every one of these, there's a little teeny bar magnet. They're all magnetized. They're all jiggled around in there randomly. But when I take this big magnet here, bring it down close, watch them. See how they kind of line up for me? Magnets are really kind of wonderful, and there's a lot of things you can do with them. If you haven't had the experience of studying magnets up close in your hands, you need to get some, and you need to do it. One of the most interesting experiences with magnets for me was getting two different magnets, turning them so North Pole, the red side, is against the red side, so like poles, because like poles don't attract, they repel. And when you start pushing these two magnets together, it's like you can feel a spring in there not letting them go together. You turn one of them around and they snap together. So if you haven't played with did I say played? If you haven't researched with magnets personally, you should order some and do that, okay? But here, we want to learn about them. We want to be able to learn how to research them. So we have 4 white containers, and as you can see, the label came off. So we don't know very much about these different containers. And quite often, when scientists are studying something, they can't get their hands inside to be able to see what's really going on. So they have to study its properties. And that's how we've learned most of the science that we know. Now, I chose these little round white boxes as mystery boxes because they make me think of what we know about magnets today. A lot of people want to know, why do magnets attract? Why do magnets repel? And it actually is pretty simple, because if you put like poles together, they attract. Now, but why? And when you start getting into the why, it gets complicated. And you can't look at a lodestone and really tell what's going on. You can't just look at a magnet and tell what's going on, because the thing that makes them behave like they do is clear down at the atomic level. It's at the very, very, very atom level. And it turns out that there are certain elements that have in their outer electron shell, remember we have different metals have different numbers of electrons, and they go in shells, and in the shells like to have 8 electrons. If they are all 8, well then all of the electrons are countered by each other, and that's what happens on the inner shells. But if you have about 3 or 4 or 5, well then those outer electrons can behave with the nucleus like little tiny invisible magnets. And we've tried so many things to figure out how they work, and I'm not going to be able to get in it today, but I'm going to tell you something. We really only partially understand how magnets work on that level. So scientists are still looking at these little puzzle boxes trying to figure it out. And now the consensus is that it's actually a quantum effect. And it has to do with Einstein's law of relativity, etc. And it's so interesting. That's worth getting a major in physics or taking our serious physics class to really learn about that. But let's start doing research on this first unknown specimen. If this was an atom, it'd be so small we couldn't see it. That's why I'm using a white box that we can't see into. We have a tool to be able to probe it to see if it can help us find out what the properties are. And this tool just happens to be a handle with some magnets on it. So I'm going to push this tool down towards the box to see if it's magnetic. Oh, look at that. It's repelling. It's repelling me, isn't it? And it's trying to turn away from my magnet. So I know that it's a magnet with a south pole. So I'm imagining that if there's a magnet sticking out here, well then probably the other end is over here. So I'm going to take my little magnet around here on this side, and you can see now it's dragging it around. So my guess, my hypothesis is that we have a magnet in here, and let's see if we can figure out exactly where it is. Somewhere around here, right there, it's got a south pole. And right over here somewhere, there it is, it's got a north pole. So I'm going to go ahead and mark it blue and red so that we know what's going on. Have we figured out inside the box that there's a magnet and it's turned that way? And did we figure it out without even peeking inside? We are scientists. Well, let's go inside and see how close we got. Look at that. We got it exactly right. There is a magnet in here, and it's turned just like we thought. So we're scientists. We're on a roll. Should we try another one? I'll bet they get harder. What do you bet? Okay, here's one. Let's get our magnet out and see if it attracts. Oh, it attracts to our magnet. And this is the south pole, so the north pole of the magnet must be right here. Let's go ahead and just mark it, north pole right there. And now let's see if we can find south pole. Maybe it's the same as the first one. So we'll turn around their side, and I'll bet here it will repel. No, it's still attracting. So let's figure this out. Must be something strange. How can it attract on both sides? Maybe it's going to repel on this side. No, it's attracting there too. Strange. We've only got one side left over here. Let's see what it's doing. And it attracts there. There's something weird in this box. So I'm going to just get one of these weird stickers and say, that's impossible. We can't figure out what it is because it attracts everywhere. Doesn't make sense. Someone's cheating. Put that away. We'll get another one. I'll bet on this one. You know what? I'm like you. I want to see what's really going on. Let's take a peek in here and see why it attracts everywhere. Oh, it's a piece of metal. And the metal attracts and it never repels because only magnets attract. This one isn't a magnet. In fact, actually, secret be known, it's a lid. A metal lid that's attracted to a magnet. So that's why it didn't repel. And the fact that it attracted everywhere should have let us know this isn't a magnet. This is just a piece of magnetic metal, okay? All right, mystery solved. Now this one, what could this one possibly be? We'll push the thing in here and see what it does. Oh, it attracts. Maybe, let's go ahead and mark this. Maybe it's just a piece of metal again. Let's find out. We'll take this off and we'll take it over here. And what does it do? It still attracts. And it attracts stronger than the old one did. It attracts every direction. How could that be? And why is it so much stronger? So it attracts there, it attracts there, it attracts there. So this is the kind of experiment that really keeps scientists up at night. Why does it attract so strongly everywhere? It attracts like two magnets would attract, but it doesn't ever repel. How could that be? There must be something very strange going on inside of this one. Oh, tricky. Some clever person hung a magnet by a string. So no matter which way it's turned, it turns to reach this magnet. So that was kind of like cheating, wasn't it? But you know what? That's what Mother Nature does. She cheats. She throws us curves and makes it very, very hard to understand. Well, we've got one more left. What do you think we're going to find this time? Let's bring it up here. Oh, we finally got one that repelled. So we know it's a magnet, and if it repels, we know that's got to be the South Pole right there. Okay, now let's go to the other side and see if it attracts. It does attract. So that's got to be the north side. So this is just another bar magnet. Can you imagine the magnet going across there because it's behaving exactly the same? That's what it has to mean, isn't it? So I'll lift off the lid to see if we're, whoops, cheaters. Two little magnets in there turned the same way. And so it looked like it was a bar magnet in the way it acted, but it was very different. And that's what I love about science, is just when you're just sure you got it figured out, then Mother Nature does a little trick.